Good morning. Hello everyone. I think all of you are ready with pen and paper to solve problems. Understanding part, most of it is done because this session primarily for those who want to revise the concept of linear programming problem and then apply in solving problems so that in forthcoming board examinations they don't face any problem from LPP. I'll explain every part of it and then some problems I'll solve with you, also solve it with me so that you get more confidence before your board exam. Linear programming, this topic is easy to score and carries 7 marks in it. So you must learn every part of it carefully. Okay? Its meaning in general is what? Just it refers to process of planning or scheduling activities to achieve a specific goal. And in linear programming, we create a mathematical model to optimize a particular objective like maximizing profit or minimizing cost subject to certain constraints. It's about finding the best way to allocate limited resources. Okay? Linear refers to something that is straight or forward, follows a straight line, and in linear programming, it means that relationship between the variables in the model are linear. You'll always find terms like this in linear programming. Terms like this one. You'll never get a term like x square minus 2y square equal to 3. That's why it is called linear. So, meaning is clear why it is linear? Because the inequation will arise in this form x plus by greater than, equal to or less than c in this form. Maybe a0, b0, maybe c is also equal to 0. Okay? A linear programming problem, I told you, it is required to efficient resource allocation, cost minimization and profit maximization in business model. It simplifies decision making for complex problem involving constraint. It has some key terms. Those are decision variables that represent choices or decisions to be made. Like if we write x plus by less than or equal to c, then x and y are variables, they will be referred as decision variable. Okay? And what are the constant? This whole thing is called a constant. Okay? In MCQ, question can arise from every corner of it. So what is the meaning of constant? That you must know. This whole inequality is a constant over there. Objective function. You are going to maximize or minimize a function which is also linear. That is of the form z equal to say px plus qy. This is called objective function, and this z will maximize z or minimize z. Okay, it will be of this form px plus qy, where pq are constant. Optimization is what? It is the process of finding the maximum or minimum value of the objective function. That is called optimization. These terms you all know, but just to make you familiar with it again, so that you don't do any mistake in MCQ also. Non-negativity condition, when you are writing something greater than or equal to 0, then that is non-negativity condition. When you are forming one linear programming problem, first you have to identify decision variable, those x and y, those are variable, no? Then you have to formulate the objective function. Then constant you have to write greater than equal to or less than equal to, and write the whole problem in mathematical terms. Like for this one, company produces two types of goods, A and B. Each unit of A requires 4 hours of labor and 3 units of raw material. Each unit of B requires 3 hours of labor and 2 units of raw material. The company has 240 hours of labor and 180 units of raw material. And profit from A, this good, is rupees 6, and the second one from B, rupees 5. You have to formulate this is a linear programming problem. So, two types of goods are there. Two decision variables will be there. Those are taken as X and Y. And profit, obviously, we will want to maximize. Everyone want in this world. Profit maximization you have to do. So, when you have taken decision variables X and Y, the objective function will be like this: maximize profit J is equal to 6x plus 5y. This is objective function. Now see, each unit of A requires 4 hours of labor, 3 units of raw material. Okay? And B, 3 hours of labor. Just note down this part. Here 4 hours of labor. It is better if you write in the form of table. Okay? Just write in the form of table. Two products are there, A and B. And this thing is, I am writing availability. How much labor hour, how much raw material available. This I am writing as availability AV. Okay? Then you first assume that number of units what you have taken, that number of units X of A and Y of B, and then you write the first row for what? What is available maximum over there? Raw material. And second one is what? Labor hour. Alright? Available raw material, how much required? For first one, 3 unit. For each, so for X unit it will be X number of product, it will be X into 3 obviously. Raw material 3. Raw material for B is what? For B it is 2. 2 units of raw material. So write it here. Now labor hour. First one 4 hours. Second one 2 hours. Availability of raw material is 180. And labor hour is 240. Okay? Labor hour is 240. So raw material, you can see that total availability is 180. Now if you manufacture X units of A, X number of units of A, here you are, and Y number of units of B, every unit will take 3 hours of raw material. I mean 3 units of raw material. So raw material required for manufacturing A is how much? Try to say how much is required? This will be what? Cx plus 2y. Because here per unit 3, here per unit 2. This will be less than or equal to 180. And here this will be less than equal to 240. Okay? Done? Check once. 240 labor hour. So labor hour in the first case is how much? Oh, sorry, first 4. So I've just taken opposite. Sorry. Just a minute, let me change it. I'll do the change. First one, this 240 hour is labor hour given, no? So you must take care. Labor hour, how much required for A? 4. And for this one, for B, 3. Check once. So this maxima is J equal to this, subject to (4x plus 3y) less than equal to 240. And raw material, that is 3x plus 2y. This will be less than 180. One condition already imposed, no one will say that. Apart from these 3, you always can write xy greater than equal to 0. Why? With x is number of units of A, so it cannot be negative. Y is number of units of B, this also never negative. So non-negativity restriction always satisfied by the decision variables. X and Y, these are called decision variables. Okay? Now, this you can form. We'll solve example. I have shared with you already. Then different type of linear programming problem. You can apply linear programming problem in many fields in our daily life. And then, question is, why should I use mathematics in our daily life? Because if you use linear programming, you can solve a manufacturing problem easily. You can solve a diet problem easily. You can solve transportation problem easily. Mainly these 3 types I will be discussing with you. See how it is solved. Just go through this sum. Check. A manufacturer has 2 depots, A and B, with stocks 30,000 and 20,000 bricks respectively. He receives order from builders PQR, this. Cost in rupees of transporting 1,000 bricks to the builder from the depot are given. How should the manufacturer fulfill the order so as to keep the cost of production minimum? Formulate it as linear programming problem. You can apply it easily, the concept of linear programming. Just in this case, you have to draw the diagram a bit, okay? Not a complicated one. Just I'll be writing here like this. These are 2 depots, A and B. Okay? Receives order from builder PQR. Take PQR here. Okay? You take just capital ones. So, PQ and this is R. 3 builders are there, they will be taking from 2 depots, that is A and B. They will take from A and B. These 3 builders. And what this table stands for? Cost in rupees of 1,000 is given. Here A This one A and this one P, from A to P, rupees 40. Okay. Next one 20. But these are all in thousands. And cost is also given in 1000. 40 bricks. For it, how much cost will be there, we will calculate. For 20, how much is required, we will calculate. So, what you will do here first, you write 30,000 here, available. Whatever available, you will be writing there. Okay? And here it is 20,000. From P, 15,000. Suppose to P is supplying X unit and B is supplying Y unit. Okay? Or you take this manner. What is the requirement of P? P needs 15,000. Q needs how much? 20,000. And R needs 15,000. Right? Now, if P receives X from A, then from here it will be how much? 1500 minus X. This one Y. So how much from here? And this one Z. This one Z. Or you don't take Z. Just check one thing. If X and Y supplied to P and Q, from A how much is left? $30,000 minus X minus Y. Clear? Because from A you have already taken X and Y. So it will be 30,000 minus X plus Y. How much will be there to R? 30,000 minus X plus Y supplied. It needs 15,000. So 15,000, just let me write, this minus 30,000 X plus Y. Just 15,000 minus 30,000 minus X plus Y. So there will be minus 15,000 plus X plus Y. Check once whether correct or wrong. This is transportation problem. You are transporting from stocks A and B to PQR. They are actually builders. So this may be cement and this may be sand. That's it. I hope you have understood this part. Allocation part you have understood. Now your problem is to write this whole thing as linear programming problem. From A to P, how much cost is there? Check. Otherwise you won't be able to write. A to P rupees 40. So this you write. A to Q 20. A to R 30. And B to P how much? 20. B to Q how much? They have given B to Q. That is 60. And then B to R. It is 40. Understood? Now what to do? You have to write all these restrictions. So you are going to minimize the cost. So how do you write? Minimize j is equal to just 40x, then plus 30,000 minus x minus y into 30, because per unit 30 is the cost. Then here 2000, no sorry, not 2000, a2 cube, it is 20 only. Plus 20y, and here it is 60. Just check once. 2000 minus y, 2000 minus y. Clear? Then this part, 1500 minus x into 20, and from here 15,000. Just simplify it. But this is objective function. Where is your non-negativity, restrictions, and those inequalities? You have to, when you are forming a linear programming problem, you have to write all. What about that? This you can get from here. That 30,000 minus x plus y is always greater than or equal to 0. Okay, this you take number 1 or you don't take. Okay, right, 1. This is 1. And next one, 1500 minus x less than or equal to 1500, and then minus 15,000 greater than or equal to 0. Therefore, greater than or equal to 15,000. Alright? Check any other restriction there or not. This is number 2 and this is number 3. Hope we have understood. We don't get any other restriction. Now one more is there, sorry. This one, 2000 minus y. Y less than or equal to 2000. So restrictions you got 1, 2, 3 and this is 4. 2 more are there. XY, number of units can never be negative. So add this. This way you can write the linear programming problem. Whatever information they have given, just see it and write the equation. Write the objective function also. You wanted to minimize the cost, that's why it's like this. Next, there may be diet problem, transportation problem, I already told you, manufacturing problem may be there. Okay? Now, your objective in LPP to solve those linear inequations, to draw all the linear inequations, find the feasible region, and then find maximum or minimum value of Z, whatever required. Got it? Finally, you have to minimize the cost. That is the aim of LPP. And when manufacturing problem is there, you have to maximize the profit and minimize the cost. Now, how to get that? Solution of linear programming problem. For that, you have to use one of these two methods, corner point method and ISO cost or ISO profit method. Corner point method is what? Suppose you have plotted all the graphs and just a minute. Suppose this you got feasible region. Then you have to find those values of J at every corner point. Why corner point? Normally J value increases or decreases with X and Y. So if I put the corner points in objective function and find the maximum or minimum value by taking this graph at the corner points only, then that is appropriate. Okay? I'll be discussing initially with the help of corner point method. But you need to know ISO cost and ISO profit method also. Stay tuned till the end. I'll explain everything one by one. Okay? So by corner point method, what you do? Graph the constant, find the feasible region, identify the corner points, evaluate the objective function, and then write the optimal solution. Okay? ISO cost or ISO profit method I'll be telling you, but not now. Let us know this thing properly by doing some standard problems. Okay, just wait. This one. This I have written in brief again. Mathematical formulation of linear programming problem is what? To write the mathematical form of LPP, we must use these steps. Step 1. Identify the decision variable and assign symbol x and y to them. Decision variable already I told you, x, y, z, whatever they take, it's up to them. That those are called decision variables. These decision variables are those quantities whose values you wish to determine. Then identify constants and express them as linear equation in equation form. Then objective function as a linear function of decision variable. And then non-negative restrictions on decision variable, as in the physical problem, negative value of decision variable have no valid interpretation. So solution always you will find in the first quadrant. It will never go to any other quadrant. Okay? That region may be like this. Region may be like this, bounded by two straight lines here. Okay? So you have to draw the region by seeing all the non-negative restrictions on the decision variable, and negative values you don't take, so solution will be in first quadrant always. It's like this. First quadrant. You never go to any other quadrant because of non-negative value. Now this is the time to do some standard problems from LPP. Let us start with the formulation of LPP first. Just read the sum. I have shared the document with you. Just read. And I told you in the beginning, you'll be solving all the sums with me. Okay? So let's see this one, number 1. Try to frame it with me. Dealer of decorative items of deals in only 2 items, wall hangings, artificial paint. He has to invest this much and the space to store at most 80 pieces. 80 pieces means that product. Wall hanging costs rupees 300 and artificial plant rupees 150. Wall hanging he can sell the price rupees 50 and artificial one rupees 80. Assuming he can sell all the items that he buys, formulate LPP in order to maximize this profit. So which part will you see first? The profit one. Let us frame the objective function first. You want to maximize the profit, so you will be writing accordingly. Maximizing J is equal to 50x 18y. I forgot to mention what are x and y. Okay. Let item 1 manufactured X units and item 2 manufactured Y units. Okay? So from every X unit, he is getting a profit of 50. So on X unit, how much? 50x. Every that wall hanging part rupees 50, artificial plant rupees 18. You have assumed that Y units should be manufactured, so Z will be total 50x here and total 18y here. Done? Now, those constants you have to write. You have written the objective function, then 15,000 he has to invest and a space to store 80 pieces. Okay? And this one costs 300 and 150. Wall hanging cost rupees 300 and artificial plant rupees 150. So 300x plus 150y less than or equal to 15,000. Now divide both sides by 150 because you will try to reduce it. Divide by 150. So this will be less than or equal to 100. This is your restriction 1. Clear? And what other condition is there? At most 80 pieces are manufactured. And non-negligible restrictions XY greater than equal to 0. Okay? So linear programming problem is formed. And we wanted to form the linear programming problem. Go for next one. Number 2. A diet is to contain at least 80 units of vitamin A, 100 units of minerals. Two foods, F1, F2 are available. Food F1 costs rupees 4, F2 rupees 5. F1 contains at least 3 units of vitamin A, 4 units of mineral, and F2 contains 6 units of A, 3 units of mineral. Find the minimum cost diet that consists of mixture of these two foods and also meets the minimal nutritional requirement. Formulate this as NPP. In applied math syllabus, formulation only marks also given. Maybe 3 mark question given, just formulate. 5 marks bigger sums, no? So maybe 2 or 3 marks, maybe 4 or 7 marks, it's up to them, but you have to be prepared. And this is very easy. If you write in the form of table. Okay? Just draw a table here. Okay? Food F1, F2. And this one, vitamin A, this one for minerals. Okay? Food F1 costs rupees 4 per unit. So that we'll do later. Just 80 units of vitamin A and 100 units of vitamin B. So availability will be what? 80 and 100 respectively. Now for vitamin A, 80 units available. So first you consider decision variables as X and Y. So let F1 and F2 are manufactured X and Y respectively. So this one F1 you have taken X unit produced, and this one Y unit produced. You have to write the minimum cost here, not the maximum one. Okay, differ from problem to problem. How do you write this? Minimum cost, how to write? See here the statement. This cost rupees 4 and this one rupees 5. You understand? So you write vitamin A in the first row requirement. And this one 2 and 3. Okay. And here cost per unit is rupees 4. Cost per unit, this one rupees 4 and this one rupees 5. Okay? So what you are going to minimize? Minimize the cost. So write the problem now. Minimize z equal to 4x plus 5y. Okay? Cost. This is cost, not selling price. Subject to, what's the restriction? Maximum 80 minutes available. Oh no, at least 80 minutes. So this will be greater than equal to. And here, and non-negativity restrictions, x and y greater than equal to 0. Clear? Hope you have understood. Go for next. One problem you solve on your own. That number 3. Then you can leave this topic. Just you can leave. Have you read? Now let me do it. Number 3. 2 bonds are there. This is not a problem from bond. Don't be confused. Just LPP problem. $12,000 in bond A and B. Bond A minimum 2,000. And bond B minimum 4,000, he has to buy it. Rate of interest on bond A 8% and the rate of interest on bond B is 10%. Hope you have written. So you just write A and B here. Okay. Interest on bond is 8%. So start this manner. Let x units of A and y units of B are bought. Okay? X units of A and y units of B are bought. So this part is X unit and this part is Y unit. Bond A. Sure. 2 bonds A and B. Bond A his investment 2,000 and this one 4,000. So how do you express that mathematically? that at most 2000 to 12,000, no? So note that statement. Total is at most 12,000, not more. So write x plus y less than 12,000, isn't it? Because total amount is investing that way only. Now, the next condition going to be that x minimum 2000. So, x greater than equal to 2000 and y greater than equal to 4000. But objective function I did not write. How to write it? Just look at this and this part. So you have to minimize the rate of interest. So write minimize subject to that condition only. Just write it here. Minimize j equal to, this you convert into rupee, 8%, so it will be 0.08 into x. Why? Because I have converted to hundreds. With 8%, no? 8% of what? That rate of interest. And this one on 10%, so there will be, alright, and non-negative condition always you will write x, y greater than equal to 0. Okay? Understood? Now let us go for next type of problem. Manufacturing problem. Not a difficult sum, try again. Or you practice at home. I will be showing you this one. How to get the maximum or minimum value by graphical method. I told you first I will be discussing graphical method. You have framed all those equations, inequations, whatever you see. Now it is your task to solve the problem. Okay? Just read. Maximize j equal to 60x plus 15y subject to this constant. This constant. You have to solve the LPP now. Be ready with the graph paper. And when you are plotting, please don't do the mistake of taking lines apart from intercept form or slope intercept form, because other forms are of no use here. So if you want to plot say x by a plus y by b less than equal to 2. Okay? So how do you solve it graphically? It will represent a region. So once a line given this form, don't take 2. 2 is a very special thing. You take C over there. Or 1. You plot it in intercept form always. This is a comma 0 and this is 0 comma b. Okay? That is x by a. Then you have plotted x by a plus y by b equal to 1. Then greater than or less than, that you can decide with the help of origin. Okay? First let me tell you, just by plotting these two, how to plot. Just you also can practice with me. Plot 2x plus 8y 2x plus 8y less than or equal to say 32. This we have to plot. And then they have asked you to plot this also. X plus cy is greater than or equal to 0. How to plot this? First one you can express in intercept form, but second one you can't. And I am telling you, most of the students, applied math students, they are facing problem in plotting also. Plotting must be correct. First one can be expressed in intercept form. Second one, straight line passing through origin. Region you decide later, but plot the line first. Say, I am going to plot this one, this one. So what do we do there? 2x plus 8y equal to 32. Divide by 2. So there will be 16. Divide by 16. So when you plot x, y, this is 10, 0 and this is 0, 4. Okay? 10, 0 and 0, 4. Now, region will be towards origin or away from origin. That will be decided. 2x plus 8y less than or equal to 32. Sorry, this is 16, not 10. You have to take the help of origin. For x0 and y0, 0, 0 satisfying this, so region will be directed towards the origin. It will be like this. This you all understand, because 0, 0 is satisfying it. Next one, x plus 3y equal to 0. If you remember little bit of straight line, then it is a straight line passing through origin and having slope minus 1/3. For this timing, I am writing x minus 3y, okay? That is why? I will explain, wait. Because if it is minus, then solution will come in other quadrant, not in the first quadrant. That's why we avoid minus sign. This is a straight line passing through origin. So that will take first. And its slope is small, isn't it? Just remove this one. This is the line y equal to 1 by 3x. And this line I have written already, that is, okay. Now for y equal to 1/3 x, inequation is this. Region will be this way or this way. It will always divide the total half plane in two parts, total xy plane. What you do there, you take the help of this point. 16, 0 you put here. For x16 y equal to 0, what do you get? Sixteen is greater than or equal to 0. So this region will be directed towards this, towards 16, 0. Understand? Most of the students, the school I am teaching here, I have checked the paper, you have done mistake here. Throughout the year. So the feasible region is going to be intersection of these blue lines and the yellow lines. Okay? Now what you have to do? You got 3 corner points, this one, and this one. The objective function value, you have to find these 3 points, here, here and here. If it is maximization problem, where you get the maximum value, that is the solution. And if it is minimization problem, where you get minimum value, that will be the solution. Okay? Understood what I told? So, whenever you are going to solve a linear programming problem, you keep those concepts in mind and let us solve this one. X plus y less than or equal to 50 and 3x plus y less than or equal to 90. Let us plot it and then solve. X and y. Today I will plot all these things. Tomorrow I will plot all these things in proper graph paper. Tomorrow there will be a session on this only, solving problems. Maximize j is equal to this, x plus y less than or equal to 50. So treat the first equation as equation only. X by 50, y by 50 equal to 1. And second one, okay. So you take points this manner. These two we are going to plot. Y by 90. So 30, 60, 90 here. And here also 30, 60, 90. Take it up 50-50. First one. So 50 somewhere like this, here also like this. First line is done. Understood? Exact graph will show you that this point 50, 0 and this one 0, 50. Next one, if you plot 30 here, next line. Just a minute. $30 here and 0.90 over there. Where? This is 0.90. 30, 0. Done? First line less than or equal to, second one also less than or equal to. So region is going to be like this. This is the region. Okay? On graph you will get this point. On graph you will get this point. But just by solving mentally I am writing the values here. It is going to be 20, 30 here. This point. So what have you do there now? You put the values of z at different points. Say that this point be A, this one P, this one B and P and this one B. Z is this. Z you find that A 1800 at P 1500, no 1200 and 4500 1650. Isn't it? Just put x20 and y30, 1200 and 2700, sorry. And Z at B, 750. So where do you get maximum value? Maximum value occur at P, 20, 30. Tomorrow I will solve more problems in the class. See you again tomorrow. Okay?